Awesome. All right. Well, let's dive in. My name is Greg Goldsmith. I'm an assistant professor of biology here at Chapman. I have been here, this is my 5th year on campus, and I'm actually happy to be back on campus. I am in my office finally. And my research group studies how water and carbon flow around Earth's surface. We study forests um, and trees and how those trees move water in particular back from the ground to the atmosphere and how those trees suck up carbon dioxide from the atmosphere. Most of what I do here at Chapman is actually to run this weird thing that you've heard of since you're here called the Grand Challenges Initiative. And so I'm going to give you a rundown of what this program is all about so that you have some sense of how it works. And then I'm gonna speed through that with the idea that you probably have some questions. And because I do not work for admissions, although they are recording me right now, I've noticed, I will answer whatever questions you've got, no matter how strange or odd they may be. So I'm going to share my screen. I'll talk at you, which is a weird thing to do because it's sort of not really what the Grand Challenges Initiative is about. We actually don't do any lecturing at all in the program. But for a few minutes, I'm going to lecture at you. And then if you've got questions in the meantime, you can let me know. I'm happy to, I'll try to keep an eye on the chat and we'll see what you want to know about Chapman University and Schmidt College and the Fowler School of Engineering. And I can tell you which professors I think are nice and which ones are really mean. All right, I'll try to share a screen here. I think everyone can now see that. And I will also try to pull up my chat so I can keep an eye on the chat. And we will play from the start. Cool. All right. So let's see. We all know why we're here. I now know what your majors are. Let me tell you what the program's all about. So the Grand Challenges Initiative, in my mind, is really about preparing you to change the world, no matter what impact it is that you want to have. I don't think that it's any secret, since it's 2021, that we've got some stuff going on out there. And we are interested in how we use science and engineering to solve those problems. So those could be problems like the one you see here, where on the left side of the screen, this is a picture by someone named Tuca Vieira. It was taken in Sao Paulo in Brazil. And on the left side of the screen, you can see folks that are living in favelas without consistent access to water and electricity and sanitation. And on the right side, you can see that everyone's got tennis courts and their own personal swimming pool. So how do we solve the problem that 1 in 8 people on the planet still don't have access to consistent clean water? We have challenges around how we will feed and distribute food that is nutritious to the 8.5, soon to be 9 billion people on our planet. We have challenges around how we respond to the increasing intensity of wildfires that we're experiencing all across the Western United States. This is a picture from Santa Rosa, Northern California. Probably some of you are from around that part of the world, but wildfires are increasing in their intensity and severity due to a climate that's becoming hotter and drier. And then, of course, as we all are painfully aware, more than 750,000 people have died in the United States in the last roughly 20 months as a result of COVID-19. And we want to prepare students to help be a part of the solution for whatever pandemics or challenges are coming down the way. How do we do this? Okay, well, so we're a 2-year program. And in the first year, we teach you how to use science and engineering to solve really hard problems. Most of the way that we do that is we spend about a semester reading lots of things and watching lots of videos and listening to some podcasts and to having lots of discussions about how science and engineering work. Like, what is engineering? How does it differ from science? Does it differ from science? How do people work together in teams to solve problems? How do you communicate what you know? We put some of those things into practice in a little mini project, but actually what we then do is we let you go ahead and start working on a project with 4 or 5 classmates. And what you really do in the Grand Challenges initiative is spend about 3 semesters working on a project of your choosing. And that project of your choosing involves developing a project proposal. You can ask for funding for that project. You can meet with experts from the field to get advice, and you get to present your results. And I'm told, oh yeah, someone from the staff is telling me that you can all see all of my notes and all of my slides, so you get a peek behind the scenes here. But I think I'm just going to stay the course if that's all right with everyone. So here we can do this. So I'm actually going to just skip right to this and tell you about the types of projects that students work on. Students work on all sorts of things. So I'm interested in you all working on ideas that you're interested in. And that could be anything from how would you stop a deepfake video? How would you reverse the effects of climate change? We're on the hot off the press of a new agreement from the Conference of Parties in Glasgow. How do you realize unlimited renewable energy? What would you do to use wearable devices to predict critical medical conditions before they happen? How do we get rid of all the plastics in the ocean? How would you reverse engineer the brain? And so students do all kinds of projects, and I'll show you some examples of those projects in a few minutes. Some of those projects are very theoretical. We have teams that work on issues around quantum foundations, and those are paper and pencil projects. But we also have teams that go ahead and do really cool things where they build prototypes. And so we've got actually now 3 makerspaces for that. We have a program makerspace. Then you can see Alex Jones in here looking at one of our 3D printers. There's probably 50, 75, 100 3D printers on campus right now. A lot of 3D printers on campus. So we have really cool things that you can use to prototype, and we have really cool tools from across lots of different platforms. So some of those tools have to do with manufacturing. We have lots of computer engineering tools, things like prototyping platforms and electrical engineering setups that you might use. We can print PCBs. We have all the chemistry and biology tools that you can think of, everything to do genetics and microscopy and environmental sensing if you're an ES&P major. And then we've got lots of software dev tools, high-end computing, access to big high-performance computing clusters, platforms to do game development, and a huge cabinet full of VR headsets and motion controllers and such. So you find some teammates and you work on a project that you care about, and then we find you a really cool mentor from our faculty. So this is some of the folks that have been in the program. They're from lots of different fields, everything from quantum computing, marine biology. There's a food scientist on there, atmospheric chemist, Let's see who else is in there. Two marine biologists, someone who is a expert in game design on there, evolutionary biologist, molecular geneticist specializing in cancer. And these fellows help you design and execute your project. And then they also become really cool resources for lots of other things, like how you write a resume or get your first summer internship, and who you connect with. And so along the way, we try to bring in experts that have lots of experience solving the types of problems that you're working on. So here's an example of a networking event. And on the screen from left to right is, let's see, Laura Herdig's at Google. Jeremy Scholes is at the chief technology officer and founder of a company that makes synthetic diamonds. Liz Breiter at that time was at SpaceX, and Megumi Hora on the right side of the screen she's a software dev at a enterprise software company called Splunk. So we have interesting networking events, and then we also bring in lots of cool speakers. So Sam Sinyangwe was with us these are the three speakers that we had last spring. Sam Sinyangwe is a data analyst for something called Campaign Zero, which has to do with collating information on police violence in the United States. Kazmika Corbett is the reason why many of you have, or I hope many of you have been jabbed in the arm twice, at least in the last 6 or 8 months. She's the scientific lead for what you know as the Moderna vaccine. She was a speaker last spring. And Matt Bernhard is really interesting software engineer who works on how you make elections more secure, both through software and through physical hardware that you vote on when you walk into a local election. So we try to create this ecosystem around your projects that helps you learn from other people and take your project to the next level. We're really using this as an opportunity to help you with 5 key things: critical thinking, problem solving, leadership, communication, and teamwork. So yes, you will learn something about code if you are working on a coding project. You will learn something about how to do gel electrophoresis if you happen to be doing some microbiology project. But really what we're interested in is the skills that you need to be successful moving forward while you're at Chapman and then after you graduate. And these skills are not an accident. These are the skills that employers are looking for. So we want to set you up. We've had an enormous amount of success setting students up to be successful going on to the internship market or onto the job market after they graduate. And I think a lot of people think that those job interviews are about the technical skills that you bring, but really nobody's asking you about an organic chemistry reaction in an interview. They want to know if you can play well with others, if you can be organized, if you have some ideas about how you would solve a problem if you encountered one in the course of your day-to-day work. Let me look briefly at the questions. Is the GCI, the Grand Challenges Initiative, part of the curriculum or optional? The GCI is required for all of our first and second year students in the Schmidt College of Science and Technology and the Fowler School of Engineering. And you would walk out with 6 credits towards graduation at the end. That's 6 out of 120. So you take a 3-credit course in your first semester and then 3 consecutive 1-credit courses. We have students from all different majors across campus that participate in the GCI. We have dance majors, we have business majors, we have majors from Dodge College of Film Media Studies. We have most majors, but it's required if you're in a science and engineering major in Schmidt or in Fowler. There is a big list of projects that we provide that includes projects that are sponsored by local organizations from the community. So there are projects like the ones that I showed you a few slides ago. And then there's projects that might be proposed by our partners. Our current partners are Earth Friendly Products. They make cleaning products. Johnson & Johnson, their medical device division. Eureka, which is a subsidiary of SAP, they're a data analytics company. They're coming on board right now. There's a couple of others. Those are projects. Or you can come to us and propose a grand challenge that you think you want to work on. And I don't think we've ever said no. So long as it's a problem with import that you're interested in, we would love to find a way for you to work on. Those are two questions that I had in the chat. Let's look at a couple of example projects. Let's see. It's been a while since I've looked at these slides. This is James Kistner, a couple of his classmates testing something, a VR experience that they made in Unity. It's about how you would sustain life on a planet like Mars. Here's a screenshot of what they developed in Unity. They were able to build out a really cool interactive experience that talked about all the different challenges that one would face if they're trying to colonize Mars, ranging from issues of soil fertility to gravity, how you would access water, things like that. A really cool project. James started his own data analytics company. He just graduated in this past May, and he's at his own data analytics company. Let's see, let me look at the classmates. Ryan Kassab's finishing a master's in computational data science. Brandon Bernardo, there were two biology majors in this group. So this seems like a software focused project, but there was a lot of biology in this, and both of those students have jobs in biotech in San Diego. When the pandemic started, some of you will recall that there was a real rush for personal protective equipment for first responders in hospitals and other medical settings. And Alex Drivas was a student of ours who had learned how to use a 3D printer as part of his GCI project, his Grand Challenges Initiative project. He got really interested in how we could use 3D printers to advance local efforts to provide healthcare providers with PPE. These are the top of face shields that are 3D printed on our 3D printers, and our students actually came together and printed about 5,000 of these face shields. They were distributed all over the US. At one point, we were printing various forms of PPE for Mayo Clinic, a world-class institution. And Alex, who studied biology or biochemistry and molecular biology at Chapman, is in his first year of a master's in biomedical engineering now at Columbia University. This is a really cool team that was interested in how we could use drones to transform our ability to respond to natural disasters. I did not want them to buy a drone and immediately fly it into the window of the office of the president. And so I challenged them to build the drone from scratch. So they 3D printed the chassis. They found instructions for how to put together a bunch of parts and did a lot of soldering and a lot of programming, and have a here's a working drone here, and it works beautifully, flies, carries a small payload, not a huge payload. They were interested in how big a payload you could put on there. And Corey McRae, who's actually, he was a data analytics, what's now data science major, parlayed this into his first job after graduation at a device engineering firm nearby here in Orange called Fusion Biotech. So some of these things may sound really, really crazy to you. And you're like, I don't know anything about manufacturing. I don't know anything about software engineering. I don't know anything about computer programming. I want to be a biology major. Doesn't matter. We'll teach you. That's what college is. Our job is to empower you with the skills that you think you want to explore and try out. All you need is the curiosity. We'll help you with the rest. That's what the GCI is about. It's about breaking stuff in the lab and setting things on fire and taking some chances and learning how to do really cool new things. Here's an example of that. This is Sonika Pandit. She and her teammates were really interested in how you would predict critical medical conditions, and they were moved by the Apple Watch. Apple Watch was way less sophisticated even then, and I challenged them to build their own Apple Watch. They did it. It had, this is what's called a breadboard prototype off of an Arduino. It had a ECG sensor, electrocardiogram, a temperature sensor, and a heart rate monitor on it, all for less than $100. About $60 worth of parts. It works beautifully. Sonika used that experience to land her first position as a National Science Foundation Summer Fellow in a really cool nano engineering program. And she's actually finishing up her thesis now. She was a biology major and was really concerned about whether or not she was going to be successful in this project because she didn't know anything about computer science. And now she's a biology and computer science double major. And I'm quite certain she'll go off to grad school next year. Okay, what do students say about all this? I met my 3 best friends in that class, and now we are all roommates. Yep, this happens all the time. The GCI is often where you meet some of your closest friends. And I see those people around campus together 3 years in their senior year, long after they finish being in the GCI, still hanging out. Way different than any other course I've ever taken. Yep, we don't do any lecturing. This is about you and your teammates working on a project together and us asking you questions and giving you the skills that you need to do that. We talked about romance novels, race relations, conspiracy theories, and mobile app design all in the same class. That happens all the time. Because solving hard problems isn't really just about science and engineering. It's about the creativity that comes from thinking about all the other cool experiences that you've had and what they might have to say about whatever problem you're working on. GCI helped me get my summer internship. Yes, we help you get summer internships because we know that much of the learning that you'll do will happen in the 8 or 10 weeks of summer. And so we want you to find really great experiences, and we work really hard to help do that. I caused an explosion in the makerspace and they weren't even angry with me. No explosions, really. We've had 1 or 2 minor disasters, no injuries. But we want you to get your hands dirty and make mistakes. Get it out of the way while you're with me, and then you won't feel as bad about it and you're less likely to make the mistake out on the job. That's what college is about. All right, there was a fast version of this presentation, 22 minutes. Let me set a ground rule for Q&A. So we have this rule in the Grand Challenges Initiative that no question is too crazy or weird. Assuming, and I trust everyone's judgment here, that you're not going to offend others that are on the screen with us. If you don't want to ask out loud, that's fine. Send me a direct message in the chat, and I'm happy to repeat the question anonymously and provide you with an answer. So I'll stop screen sharing here if I can. And I would be very happy to hear any and all questions that you've got for me about the Grand Challenges Initiative, about Schmidt College or the Fowler School of Engineering, the majors, or the university as a whole. There's a question in the chat, is this only for 2 years or can it be longer? I have teams that work on their projects for all 4 years. Earlier today, I was helping a team that is in they're 3.5 years into their project. It's a project on functional seizure disorder, what was historically known as psychogenic non-epileptic seizures. And their paper looks like it is going to be, they wrote a really fascinating case study, and it looks like their paper is about to be accepted to a peer-reviewed journal called Epilepsy and Behavior Case Reports. And that really was, actually, 2 of those students will graduate at the end of this semester. So that really was a 3.5-year project, start to finish. Do all STEM majors have equal time and access to the labs and 3D printers? Yeah, I'm actually very impressed with, so our makerspace for the GCI is open about 20 hours a week outside of class, and we've never had a problem with students being able to access it. There's 2 additional makerspaces now. One is really an electronics and robotics space in the Fowler School of Engineering. The other is really more about additive and subtractive manufacturing. And I think that any and all students are more than welcome. And in fact, I think that we're all secretly really excited when a student from a major that you might not expect to use those spaces walks through the door, like a math major. Do you have to work on the same problem during the program, or can we try to solve multiple problems? I've never had a team solve the problem within the course of a program. That's what's beautiful about science and engineering. So I think that my instinct is that you would find yourself working on the same problem for 3 semesters. And I think that's a really important experience to build some real depth of knowledge about that problem. And then you supplement, you build breadth out on what you know through your summer internships or through working in somebody's lab group in your junior or senior year, or even your sophomore year. So my experience is that the teams do spend all 3 semesters, which goes by quite quickly, on the same problem, and then they look for other problems in other experiences. Have we had a project surrounding dementia and cognitive decline? We have a project right now. Yes is the answer, and I'm thinking of a project as an example right now. We have a project right now that's with, it's a partnership with Johnson & Johnson. It's very cool because that team is interacting with a very cool scientist from Johnson & Johnson named Rosanne Blandman-Blanche. They meet with her a couple times a semester, and they are comparing 2 approaches to memory loss. That would be classically associated with dementia or cognitive decline. one is a paper-based approach and the other is an app-based approach. And if you look through, it's not my field, but my take is if you look through the research, there's not a lot of research about whether a mobile app is fundamentally better than a paper-based approach to memory. And so they're doing a very cool study comparing paper and memory based approaches. That's the team that comes to me right off the top of my head. There's about 100 teams participating, so there may be other teams that there are teams I'm sure I'm not thinking of. Other questions? Happy to take questions about the majors or about the university or about Orange. I don't know where everyone is tuning in from. There's been research on the average time that it takes people to formulate questions. It's something like 7 seconds. So I try to count in my head to see how if I can wait 7 seconds and let folks come up with new questions. How often do we speak with past students? All the time. Probably multiple times a week, actually. I can, let's see, who did I talk to this week? Monroe stopped by. She graduated in the spring. She's about to move to New York City. She's taking a job as a legal analyst who on her way to law school. I just talked to Kendra Ellertson this week. She has now been at a really cool vertical farming company as the lead grower. So they grow produce largely for Whole Foods. I talked to her this past week. I think that many of our faculty stay in very, very close touch with our students as they make various transitions in the first couple years out of their undergraduate degree. And this is letter of recommendation season for us. I've probably written more letters than I care to tell you about. And those, we also keep in touch with students because we want our students to come back and talk about their experiences and serve as mentors for our current students. So we want community continuity. We want Chapman students to feel that they can reach out to alumni for assistance. Last week, we had a career panel that had Emily Hanna. She left Chapman, got a master's in public health from UCI, and is now an environmental health specialist for Solano County, Northern California, in the Bay Area, as well as Amy Lamb. She was a physics student, did a lot of optical chemistry, and is now actually a mechanical engineer nearby. Let's see, other questions that have popped up. What kind of research opportunities does a first-year biology student participate in? Well, there's a couple different flavors of research opportunities. So there's the things that you'll see as a first-year biology student in lab settings associated with classes, Typically, you would take Introduction to Cell and Molecular Biology in the fall, that has a lab, and you would take an Ecology and Evolution course in the spring, that has a lab. And then many students in the spring of their first year may start to shadow other students within a lab like mine, with the idea that they would join that lab in their second year. But the GCI really stands in as a third form of a research experience, even if you're not quite yet embedded in a lab. We generally advise students to get through certainly their first semester, but often their first year before they dive completely in to join a lab, because this is a big transition. And everyone that's on the screen will be coming from an even bigger transition, because you had a chunk of high school that was online. So we need to make sure that you're set up well academically and socially, and that you can take on some additional things like another research opportunity. As a first year, are you grouped in a residence hall with others in similar major STEM students? The answer is yes. It's right across the street from the Science Center. Housing's good. Certainly better than when I was a first year, which was actually not that long ago, but feels like a long time ago. The building that I was in was built in the late 1800s and felt that way. These are modern dorms. They're good. They're close by. Dining hall seems fine. Been there a few times. And you would find yourself with other STEM majors. Yes, that's correct. Robotics programs for first year. What is the track and how quickly? You would see elements of robotics almost in your first semester, really. So a student in the Fowler School of Engineering would take Engineering 101 in tandem with taking the GCI. Engineering 101 is also a project-based course, and you would see lots of prototyping of devices and mechanical, both the hardware, the software, and the physical device. So, the elements of robotics happen very quickly. You may need to get through some lower division courses before you take a upper division robotics course. And I have to confess that I'd have to go look at the catalog to tell you where that would fall in the sequence. I can do that, and I'll give everyone my email address if you want to follow up after the fact. Is there any direct instruction from a mentor, or is it mostly like learning by doing individually? Yes, you see your mentor all the time. See them every week, twice a week in the first semester, once a week in subsequent semesters, and that person is there to help facilitate each team by asking lots of questions, by pointing out resources, by connecting you to other people. But we are, over time, we're trying to give you the skills that you need to be increasingly independent and more and more sophisticated. So, and I would never call this learning by doing individually, because we're a team-based approach. So it's more like learning by doing with 4 or 5 classmates under the mentorship of one of our faculty. Hopefully that clarifies that. What we don't do, or what I wanted to distinguish between, is the GCI is not someone standing at the front of the room lecturing at you the way that the way that you might imagine a college experience to look like. We're really interested in you engaging more directly in material, as a rule of thumb, in both Schmid and Fowler. We know that you learn more by doing that. These are all great questions. No one's thrown me any hardballs yet, but these are good questions. Have any STEM students that you know have changed their major after participating in the GCI program? If so, why did they do it? The biggest change that we see is biology majors moving to health sciences. And I think there's lots of different reasons that students do that. Sometimes they say that it's the GCI. Sometimes they realize they just want a more focused program. That's fine. The majors are very similar. The GCI is not that many credits at the end of the day, 6 credits. Everyone has to take an FFC anyway, so it's really only 3 additional credits. I do think that if I were to rephrase this question, what makes the GCI hard would be the way that I would rephrase the question that's in the chat. This is very different. It's very different from what you would see in high school chemistry or biology or a high school comp sci class. No one is handing you the answers. These are real problems. They're very hard. And I think students are taken aback by that challenge and by all that's involved in wrapping your head around some of these things. And so that can be a big adjustment, but you have to make that adjustment. We want you to be successful making that adjustment because we have to get you ready for problem solving after you graduate. Are the courses always taught by the professors or are there TAs teaching as well? So there's no TAs in the classic sense of a TA. TA, for those of you that may not know, is classically associated with a graduate student who's still training. Everyone that you see in the GCI has a PhD. They all have doctorates in STEM fields. There are 2 full-time faculty, me and an assistant program director, and then there are postdoctoral teaching and research fellows with PhDs who serve as provide a lot of the facilitation. They're amazing. They come from all over the world. They have so much energy, so much excitement, and so much enthusiasm. They consistently have the best teaching evaluations of the college because they're so excited about being in the classroom with you. And so you never see in the GCI anyone that doesn't have a doctorate in STEM. Oh, I'm being told that there was maybe a virtual instruction question that I missed. Oh, is campus face-to-face now or virtual instruction? We're in person. We came back for the fall. It's been, I think, pretty smooth. There was bumpy getting everyone back onto campus. We have a vaccine mandate on campus. More than 90% of campus is vaccinated. We do have a mask mandate right now. I don't know what the future holds and what variants will arise out of COVID-19, but I'm cautiously optimistic that the key vaccines in the United States are holding up very well to variants, and so I hope everyone, cross every finger you've got that we continue to see progress, and that will remain in person. New majors coming up in engineering. Yes, but I'm not at liberty to say. We will never have civil and we will never have mechanical, I don't think, because we don't have the space for those things, really. But engineering is growing incredibly rapidly. There'll be something like 25 new faculty in the next 2 years within engineering. Maybe that's a 3-year trajectory. Many new faculty are coming to engineering with lots of different expertise, and there will be some cool new things coming down the line that I imagine would be relevant for this incoming class. Yes, but I can't quite say yet. Sorry about that. TAs teaching in the university as a whole. The only place that you might have a TA, we don't have a lot of graduate programs on campus. I don't know every single program and where they place people. On the whole, you're really getting a professor. There are some places where you might have a lab section where the lab is led by someone who does not have a doctorate, who's a graduate student or somewhere in their trajectory. In Schmid College, I can think of a few places where you were in labs where you would have a TA, but that's coordinated by a professor. But no, I mean, part of what makes Chapman is that on the whole, you're getting a professor with significant training. If you could change thing, now we're getting to the. It took you a while to warm up. Now we're getting. If you could change one thing at Chapman, what would it be? That's a hard question. My perspective may be very different from the student perspective. So that's hard for me to say. I would really like for us as a university to continue to grow our national reputation. I think that we are an amazing, amazing institution. We get great students. I have incredible colleagues and staff that are very, very supportive. A national reputation, and our reputation has increased enormously in the 5 years that I've been here. As that continues to increase, it will continue to open more and more doors for our students. We should, for instance, we should have a Rhodes Scholar most years. We're now starting to have Rhodes Scholars, Goldwater Fellows or Goldwater Scholars. We should have that every year. Now we're starting to have one every year. Things like that would open new and different opportunities to our students are coming, and I'm excited about those. And I would love for Chapman to be more and more of a household name. A phenomenal institution. Doesn't have the reputation yet that it deserves. What's the student professor in comp sci classes? Depends on the level of the class. It gets smaller as you get to upper division classes. Most classes that I see have 25 or fewer students. Upper division class may have 10 or 15. A big class at Chapman in the sciences would be 50 for a lecture, an introductory lecture. That'd be a huge class, huge. GCI, our classes are 25, but closer on it. I think the average is actually closer to 18. What tools are we using to evaluate the program, and are the results available on Chapman's web pages? That's a great question. We use lots of tools. Most of our assessment is not available on, is not outward facing, and unless you really go search for it. Sarah Buckley, can you put the GCI blog into the chat for folks to see? So what I'll share with you is a web page with all the student projects. So you can look at what students actually do. I think that would be fun and different. We are in the middle of a long-term assessment of student self-efficacy, if you will. So how confident that students are students feeling that they can go out and use these tools. And we previously did a long-term assessment of scientific literacy skills, quantitative reasoning, ability to find and evaluate information, some other things like that. That looks good. And probably our most consistent evaluation is actually through how students write and what writing students turn in. And we do see gains semester over semester through that. But we haven't yet publicly put a lot of that information out. Not for any particularly, we're not trying to hide anything. And if you'd like to email me, I'd be happy to share whatever we've got. So I'm going to give you my email address. I'm very easy to find. Because as someone alluded, many people are emailing me, all of our alumni, etc. It may take me a day or two to get back to you, especially right now, because we're really right into the heart of letters of recommendation for graduate school applications. But I will get back to you, and if I don't know the answer, I will forward you along to someone who can get you the answer. I'll stick around if folks have a few more questions, but I really appreciate everyone taking the time. The Grand Challenges Initiative it's a really unique program. I'm really proud of what we've been able to do and how we've been able to empower you to learn about the things that you want to learn about and to provide you with the skills that we know that you'll need to be successful for the rest of your experience at Chapman and moving on afterwards. I hope that you come visit campus if you haven't already, and that you keep us at the top of your list. And the day, and again, I'll stay if someone wants to ask a few more questions. Thanks so much.